Hello everyone and welcome to the session. Today we are going to discuss the single responsibility principle in solid design principles, and we will try to understand a basic thought process behind SRP. So let's start with the definition. Every software component should have one and only one responsibility. Software component here could be a class or a module, but it should have a single responsibility given to it. Let's take a look at the real world example now. The image on the left is a Swiss knife. It's a multi-purpose knife. It has large blades, key rings, scissors and hooks as well. So, for real life, it's a very useful tool. But in software design, it's not a very good thing. Clearly, it's violating single responsibility principle. So, what could be a good example? Let's see another example of knife and scissors. Now, these two are different objects and each of have their own purpose. So, these are following SRP. This kind of design in software world is good. Don't worry, we will see in a bit why it's a better design. Let's talk about the elephant in the room. What exactly is a responsibility? And unfortunately, there is no exact answer to this question. Different developer might have different opinions about the term. This is logical but not practical in development. So we will change the definition a bit and it will become every software component should have a single reason to change. This definition again seems a bit fuzzy, but now we can say that a class follows SRP if you can't think of more than one reason to change. So if you just take a look at the class and try to think reasons for it to change and can't think of more than one reason, well, it's following SRP. So this definition is suitable for practical real world scenarios. But why? Why only a single reason? What if we have multiple reasons to change? Well, in that case, if there are multiple reasons to change the code, frequency of code will change as well and it will go up. With the increase of frequency of code change, there will be increase in probability of introducing bugs as well. Hence, the cost of maintenance will go up. So, as an example, we can take a look at our Swiss knife and think of a reason to change. Maybe we want to change the blade, scissor or hook. Let's suppose you have to change the blade. Then you have to separate out other components as well, such as can opener, hooks, scissors or keyring. And there is a probability that you can't fit them again. But why in the first place we have to deal with the hooks, scissors when we just wanted to change the blade? Well, the reason for that is they are coupled together and we can't just modify one of them. So for fixing the blades, you need to deal with all of the other components and maintenance cost in this particular case will be much higher. Now let's take a look at these images. Suppose you have to sharpen the knife. Then you can just easily do that without affecting the scissor. So maintenance cost in this particular case will be low. Let's go through a few of additional terms as well. So the first term we are going to look at is cohesion. It is defined as a measure of degree to which the element of the modules are functionally related. So let's assume there is a class which contains 4 methods and 2 of them are sound related and 2 of them are related to rendering the video on the screen. So there is a low cohesion. Why? Because the sound methods are not functionally related to the rendering methods. So we can create 2 separate classes, one for the sound and one for the rendering. Then there will be an high cohesion between these methods. So in SRP, we should focus on high cohesion. The second term which we will be looking at is coupling. It is defined as the interdependency or degree of relationship between multiple modules or components. Now, let's assume a class which contains 3 methods. 2 of them are related to setting the information and updating the information, but the third method, it actually saves the whole information into a file. So this method deals with the backend details like how content is stored at the backend. But we have coupled it with the set and update information method, and this is not a good design. A better solution will be to separate it out and create a new class just to save the information into a file or probably into a database. So in software world, it's a good technique to have low coupling.